Good morning. I am Dr. Sanjay Jain, Associate Professor in Mathematics at SPC Government College, Ajmer. Today we are taking the lecture on tensor analysis. Earlier we are taking a lecture on tensor analysis in which we are included covariant tensor, contravariant tensor and properties of tensor, and then Riemannian metric tensor or fundamental tensor. Today we are taking a special type of tensor known as Christoffel tensor. Here we are taking definition of Christoffel's tensor or symbol. It is better to saying Christoffel symbol because the definition we define is not in a tensor. So Christoffel symbol is better to sing. In 1869, Christoffel, a mathematician, introduced certain functions involving derivative of the component with the metric tensor or fundamental tensor Gij in such form. These are the two forms in which we are taking fundamental tensor relation or represent in that way I, j, comma, k. This is in a row notation, and in the second line, k, I, j is in a column representation. Okay, so both are known as Christoffel symbol of first and second kind. What we are doing here, derivative term of fundamental tensor del Gik over del Xj, because J are missing in Ik, plus del Jk, here I is missing, so differentiate with respect to del Xi minus del Gij over del Xk. Here one thing is an important, the minus sign taken with Ij. Ij are the two indices in the notation, first two indices. So, and third indices is alone k. So, with third indices, whenever differentiate with third indices, we have taken negative sign. So, this is the representation of first kind of Christoffel symbol as row notation ij comma k. Now we take the column notation kij. Okay, this is nothing but the second fundamental tensor glk ij comma l, denoted by column notation. So these ij comma k and kij are known as Christoffel symbol of first and second kind respectively. Now, inner multiplication of this equation 2 with GKP both sides. What we get here in equation 2, multiply GKP both sides. So we get GKP Kij is equal to GKP GLK Ij comma L. Okay. So GKP and GLK become conical LP, means L and P, when L and P are equal to 1, conical LP becomes 1, otherwise it is 0. So we substitute L equals to P, we get IJP. So what the difference you are getting here, that the first and second kind Christoffel symbol related in the second equation with GLK in the row notation, while in this form ij comma p is nothing but equal to gkp kij. So in both these relation they are interchanged, column relation related with row relation, but in the later row relation related with column related Christoffel symbol. So both can vice versa can change by inner multiplication of the suitable fundamental tensor. Okay, so this is the definition. Two kind of fundamental tensor we have studied later on. One written in the row form ij comma k, and second is kij, not saying any covariant or contravariant, because these are the Christoffel symbol, not the tensor. Okay, now we are taking symmetricness of the symbols. In the above definition, in earlier page we have taken of Christoffel symbol all the indices except one, that is except k in the second kind symbol are subscript. Okay, otherwise upper is subscript or lower subscript. Okay, the exception k in the symbol of the second kind is regarded as superscript. The expression on the right hand side of 2 is the summed up with respect to the repeated indexes L. It is clear from the above definition that the function or symbol ij, comma k and kij are symmetric in the indices I and j. This is main important thing. In first two indices they are symmetric. How we can say, or how we can see? It is very easy. I j comma k and k j I comma k can be written by definition form again, and you find both are equal. Okay, in that here you can see, if in first two indices you change I and j, you get ij comma k is equals to ji comma k. Okay, so we can easily say that ij comma k is equals to ji comma k, and kij in column form is equals to kji, since fundamental metric tensor GIK is equals to GKI. We already seen that fundamental tensor are symmetric. Therefore, these two type of Christoffel symbol are also symmetric type, having the property of symmetricness. Okay, from one it follows immediately the definition we are putting here ij comma k plus kj comma I, putting the definition of these in the form, and we get del gik over del xj, because gij is equal to gji. So cancel these terms on, we get only sum of the two of same type Christoffel symbol can be expressed in derivative form of fundamental tensor. Okay, so this is symmetric type. Now we are taking a relationship, derivative relationship. This is a derivative relationship. The del gik over del xj, which we see in the last line, can also represent in the other notation of Christoffel symbol. What we are seeing here, this is in a relation ij comma k, kj comma I, del g ik over del xj are the derivative relation in first term of Christoffel symbol. Now we taken second form of Christoffel symbol with the derivative relation. What we are doing for this, to get this, we are taking just the identity g IH GIK is nothing but conical KH. We know that. With using this, we differentiate with del xj both side. Conical KH is a constant term, therefore the right hand side term becomes 0. And now the important thing, the plus quantity of second term taken right hand side, so it becomes negative. Now del GIH over del XJ can be written sum of these two form as we saw in the equation form in the last page. Okay, so after putting this, now multiplying both sides by GHL, inner multiplication both side, and after multiplying both side it become conical by using 2. This become conical Li, and GHI, this become second kind notation. Easily you know that this may be written in the second form of Christoffel symbol by definition. So by taking conical Li, putting L equals to I, and this term in this form, we get the, now this is in the differentiation derivative relationship of the Christoffel symbol of second kind with fundamental tensor. Okay, so we are seeing derivative relationship both type Christoffel symbol with the fundamental tensor. So today we are stopping here. In our next lecture we are taking the properties of Christoffel symbols. Okay, thank you.